let's look at proposition number 4 of On the Sphere and Cylinder, book 1 of Archimedes works. The proposition says, again, given two unequal magnitudes and a sector, it is possible to describe a polygon above the sector and to inscribe another in it, so that the side of the circumscribed polygon may have to the side of the inscribed polygon a ratio less than the greater magnitude has to the lesser magnitude. So what the proposition is saying is that it is possible to circumscribe a polygon and inscribe a polygon in this sector such that the ratio between the side of the circumscribed polygon and the side of the inscribed polygon will be less than the ratio between the two given magnitudes. So let's see how we can prove this. Let A and B represent the two given magnitudes such that A is greater than B and also given a sector DOC. Now find two straight lines F and KL where F is greater than KL such that F is to KL is less than A is to B. And we have already seen how to do this. So I'll just put it up. Now draw LM perpendicular to KL. Again, this follows the same procedure that we have already seen. LM perpendicular to KL such that KM is equal to F. So we have already seen how to make sure of that. Now, in the given sector DOC, let OC and OD be the radii. Bisect DOC at M and let's join NO. Now, repeatedly bisect one of the bisected angles till the bisected angle is less than 2 times the angle LKM. Now, in our case, NOC is such a angle. Join NC. Now, bisect NOC at P so that OP is the radius of the circle. So, we again bisect NOC. OP becomes the radius of the sector or radius of the circle whose sector is the given sector. Now, H is the intersection of OP and NC. So, let's mark it as H. Let the tangent at P meet OC and ON extended at S and T. So, we extend NO, OC, and we draw a tangent at P and take the intersections. And now we can remove these lines. And let's join ST. That means now we can actually have the inscribed and the circumscribed polygons on this sector. So this is the inscribed polygon and this is the circumscribed polygon. And if you notice in these polygons, two sides are the radii or along the radii. Angle HOC is less than LKM since NOC is less than 2 times LKM. NC is the side of a polygon inscribed in the sector and ST is the side of the polygon circumscribed on the sector. OP is perpendicular to NC at H and HN is equal to HC since OP is the radius of the bisecting angle NOC. MK is to KL is greater than OC is to OH, since angle OHC is equal to angle KLM, where both of them are right angles, and angle HOC is less than LKM. So because of these two conditions, we can say MK is to LK is greater than OC is to OH. But OC is equal to OP because they are the radii of the same sector. So which means MK is to LK is greater than OP is to OH. MK is to LK is greater than ST is to CN, since ST is to CN is equal to OP is to OH. This is because of the similarity of the triangles. Triangle CON and SOP. Now, since MK is equal to F, we can say MK is to LK, or rather F is to LK is greater than ST is to CN. But the proposition talks of lesser. So let's reverse this and say ST is to CN is less than F is to LK or KL, because MK and F are the same. So here ST is what? Is the side of the circumscribed polygon. And what is CN? CN is the side of the inscribed polygon. So since ST is to CN is less than F is to KL, and F is to KL is less than A is to B, that means ST is to CN is much lesser than A is to B. So we can say that the side of the circumscribed polygon is to side of the inscribed polygon is less than greater magnitude is to lesser magnitude in case of a sector, which is what this proposition is talking about. So that is proposition number 4 of On the Sphere and Cylinder, book 1 of Archimedes works. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.